Welcome to Scientists and Models.
At the beginning of the school year, when we were studying scientific ways of thinking, I mentioned that models have to be used a lot in science. And as we study Earth and space, we're going to find out that models are very important, especially in this unit. And over the years, I've done a unit with my students where we kind of understand what it's like for scientists when they had to discover all of the things with Earth and space, like the things we know today, we just take for granted because it's been discovered, it's been proven, and we're still getting more information. But that's not how it's always been. Think about COVID-19. In March, we didn't have a lot of information, and there was a lot of different things going around, and people thought different things. And then as scientists have learned more and studied this virus more, they have learned more about it, and then they can tell people accurate ways to try to prevent it or treat it if you get it. So, we can think about Earth and space in a lot of the same ways because it's not something that we can easily observe so that we can learn more about it. So we're going to look at some of the history of that, and I'm going to read from this book. It's called Models and Designs, and it's really a science kit that I usually do with my students. But there is a really awesome article in here called Scientists and Models. And all right, we're going to go ahead and read Scientists and Models. So I'll show you the pictures as I read. Scientists and Models. Why a model? So scientists, when they're studying the universe, they can't fly out to the far reaches of space and see what the stars look like. Some systems are too big or too small to be directly observed with the senses. A model describes how a system looks and works based on the best scientific evidence of the time. A model is a statement of what a system is. Taken together, scientific models describe how the world works. So we're going to be using models to describe these concepts for Earth and space, how it works. Because scientists can't always see the systems they are trying to understand, it's difficult for them to make physical models. Science relies heavily on conceptual models, but ideas in a conceptual model might be just guesses, or they might come from experiments and observations. Once a conceptual model is described, other scientists can work with it. New inventions help this process. For example, telescopes helped astronomers change their models of the solar system. When observation shows a flaw in a model, the model is changed. A model is useless if it doesn't accurately describe the system it represents. So we're going to talk about two different kinds of models here. We have physical ones. Those are the 3D ones, like a globe. And then a conceptual model can be like a drawing. It's two-dimensional. It can be an idea in your head. It can be mathematics. But it's looking at a concept. So, a 3D one you can really manipulate, and a conceptual one you can't. All right, so we're going to look at studying the stars. Some of the best documented conceptual models were created to explain our solar system. The first humans looked up into the sky and saw the sun. At night, the stars and the moon glowed overhead. People wanted to explain what these objects were and why they moved across the sky. They wanted models to explain their world. So you can see that picture right there where it says, an early astronomer studies the night sky. Some of the early astronomical models were religious. Ancient Greeks called the sun a god named Helios. In Egypt, the sun was the god Ra. In the world model developed in ancient India, gods lived on a high mountain to the north, and the sun was always shown there. The planets moved because they were pushed by a holy wind. Religion and science often worked together in ancient times. Priests were among the first astronomers. They studied the movements of the moon and stars to create calendars. The ancients knew the changes of the moon from full to quarter to new and marked the passing of time by these phases. Simple tools helped ancient people develop better models of the solar system. The Babylonians used a tool called a gnomon. This rod was used to measure the lengths of shadows. The shortest shadows came on the longest day of the year. The the summer solstice. And the longest shadow came on the shortest day of the year, the winter solstice. Of course, a gnomon wasn't very useful on a cloudy day or at night, but any tool can be useful if it adds new information to a model. So changing a lasting model. This is really what I thought of when I thought of this article, and I wanted you guys to hear this. The most famous ancient astronomer was a Greek named Ptolemy. This mathematician and scientist lived in the 2nd century. Like other astronomers of the time, Ptolemy thought that the Earth was the center of the universe. The moon, the sun, and the planets moved around Earth in huge circles. Ptolemy recorded the idea of the great Greek astronomers before him and added new observations about the stars. His book, the Almagest, was Europe's major text on astronomy for almost 1,500 years. Ptolemy's model for describing the universe was sometimes called the Ptolemaic system. No scientist seriously challenged that idea that the Earth was at the center of the universe until the 16th century. So 16th century is the 1500s. So we're talking about like over 500 years ago. All right, so nobody challenged it that the Earth was in the center until the 1500s. It says, then Nicholas Copernicus conceived a new model of the universe. So Nicholas Copernicus lived from 1473 to 1543. So like I said, we're looking at about 500 years ago. Copernicus was a Polish astronomer who also studied law and medicine. Using math and the astronomical tools of his day, Copernicus studied the movements of the sun and stars. He concluded that the sun was at the center of the universe. The Earth, the other planets, and the stars revolved around it. In today's model of the universe, we know the sun is a star at the center of our solar system. The universe has other stars and probably other solar systems. The Copernican model was not accepted at first. It clashed with deeply held beliefs, including religious beliefs. But over time, other scientists agreed that this new model of the universe was right. They also added to Copernicus's ideas. One later model of the universe said it is infinite. This means it stretches on forever. Copernicus, like Ptolemy before him, thought the universe had a definite end. So let's kind of revisit this here for a second. So for over 1,500 years, people thought that the Earth was in the center of the solar system. And so then Nicholas Copernicus came along and made observations and said, no, the sun is in the center. And think about that. People do not like change. You guys know that, right? Even when science proves it. So, think about how this time period back then, how hard it would be for people to change their thinking. And that's something today that we just accept. And we can also kind of prove it through some of the different labs that we're going to do. We're going to be able to make those observations. But it's just interesting to think about how, we have grown and a lot of those models just continually change as we get more information. I'm going to read one more little section in this article. I am skipping little parts that aren't as applicable, but I just think some of this is very interesting, and it's interesting to think about all of the discoveries that people made so very long ago using different kinds of technology. We have very sophisticated technology today, but we're going to be talking about the 1500s and people figuring these things out, and they did not have the same kinds of technology that we have today. So, all right, we're going to listen to support for a model. Scientists rely on observation to help prove or disprove their models. In 1610, the Italian scientist Galileo Galilei, he was from 1546 till 1642. He used a telescope to observe the planets Jupiter and Venus. Galileo had built the scope himself, improving on the design of an existing telescope. With his telescope, Galileo discovered 4 moons circling Jupiter. He believed the Earth's moon probably circled Earth in the same way, just as Copernicus had said it did. He also saw that Venus had phases just as the moon did. It could be seen in full, in quarter, and as a crescent. To Galileo, this observation proved that Venus and the other planets did revolve around the sun, as Copernicus had suggested. Today, scientists use incredibly powerful telescopes to test new theories about the universe. One of these telescopes is actually traveling in space. The Hubble Space Telescope sends back images of regions of the universe that cannot be seen clearly from the Earth's surface. Let's go ahead and watch that models video from the beginning of the year to review what a model actually is and why we use them, because we're going to be using models a lot during this Earth and Space unit.
Welcome to What is a Model? A model is a representation or explanation of something that shows how it looks or how it works. So why do scientists create models? Scientists make models of things that are very big. For example, let's look at Earth. Earth is so large that it makes it very difficult for people to study it. So we make models. I bet you're familiar with some of the models of Earth. Can you think of one? How about a globe? A globe is a physical model of the Earth. We can see the spherical shape of the Earth and also move it like Earth rotates. That's not our only model of Earth, though. A paper map of Earth is a conceptual model. We can use it to find locations on Earth. I have one other model example for you of Earth. Even a map that you find on a device is a model that can help you learn about Earth. So we use Earth as an example of seeing how scientists make models of things that are very big. Scientists also make models of things that are very small. Scientists created a model of DNA. DNA is located inside each of your body's cells, and it's a genetic code that decides your unique features. So scientists created this because it's way too small to see your DNA. This is a way big blown up version of something that's very teeny tiny. We know that we can't see COVID-19 with our eyes, so scientists have created a model to kind of explain to us what it looks like and how it works. And as scientists get new information, they change their models. So far, we have learned that scientists create models for things that are very big and very small to better understand them. But there's another reason why scientists make models. They make models of things that are impossible to see into. A great example is your body. A skeleton is a fantastic physical model. Scientists can use this to help us understand about the bone structure of the human body. At the eye doctor, you can see a model of the human eye. This can help you better understand how the eyeball works. Both the models of the skeleton and the eye are used to help people better understand our human body. We can't easily observe these parts, like our bones or all of our eyeball. To review, a model represents or explains how something looks or works. People make models of things that are very big, like the Earth or the solar system, very small, like DNA, COVID-19, or impossible to see into, like our bodies. What models can you think of? Be on the lookout and see if you can find some. All right, so now you remember some of those model concepts. As we study Earth and space, we're going to be using different kinds of models, and you'll see that I have a variety of models for Earth and our planets and our sun, and I will always give you some different options to try to find something that you have at home so that you can do it as well. I know that you were given those science kits at the beginning of the school year, and we have not really used a lot of that stuff, so anything that you can use from that kit as we move forward to do any kind of lab, please use it because that's what it's there for. It's for you to use and for you to learn. So I don't want any of the stuff that we're learning to cost you money. I try to always show you some things that we can use at home, things that are at like in your science kit, or just things that maybe you don't have that I can just show you that I have. So, all right, so I'm excited for us to get started on our Earth in space. So enjoy learning about Earth in space, especially with these models. That's all for me. Take care.
Peace.